Hello everybody, I am here with another example of how we can use the relative motion and apply to velocity analysis. This time for a rolling motion. This is a typical motion that clearly you could see that this is a combination of translation and rotation. So the body is going through combination of translation and rotation. So typically remember we need velocity of one point on the body and omega of the body. So here I gave you omega of the rolling body to be 8 radians per second and velocity of A is 80 inches per second. So at this instant velocity of A is given to be horizontal and 80 inches per second. By the way, there is a relation actually between the radius of this rolling disc or rolling wheel and omega. It turns out that velocity of the center of the wheel is always r omega, by the way. So velocity of A, only center. So r is 10 and omega is 8. So that's why we get 80 inches per second. But in any case, you'll see that much better when we'll do the graphical approach, the instantaneous center approach. Okay, so now what we want to do is we want to find at this instant velocity of B, velocity of C, and D. All of these points are sitting on the rim of this disk. C is the contact point, D is right here on the rim, and B is right above A. Okay? So remember, the radius is 10 inch, and this guy is rolling at 8 radians per second. So let's go and do this. So I'm going to explain what this picture here is in a minute. So let's start with B. Using the relative motion analysis, we say, okay, velocity of B, let's translate with A, and let's rotate about A. So remember, the first term is the translation part, the second term is rotation part. What is VB slash A? VB slash A means what? Means find velocity of B as if A is fixed. And this is the picture that I've drawn here up here for you. See, if I make A fixed and I want to find velocity of B here, and this guy is rotating clockwise, right? So velocity must be equal to what? VB slash A must be equal to R omega. R is the distance between A and B, right? That's 10 inch, the radius, times 8 radians per second. So that becomes 80 inches per second to the right. So let's go and plug in. So velocity of B becomes velocity of A. Velocity of A is already 80 inches per second to the right. Velocity of B relative to A is also 80 inches per second to the right. So that becomes 160 inches per second to the right. So far, you see velocity of B is going to be like that. Actually, twice velocity of what? A. Velocity of A is 80 inches per second. Velocity of B is 160 inches per second. All right, then now you got the idea. Do the same thing for point C. Velocity of C is equal to velocity of A. Use A as your reference, plus velocity of C relative to A. So what is velocity of C relative to A? I use the same picture. It's also R omega. It's velocity of C as if A is fixed. Guess what? This became 80 inches per second, right? This is going to be also 80 inches per second. But look at its direction. It's to the left. So look what happens. I have 80 to the right. That's velocity of A. Velocity of C relative to A is 80 to the left. Whoop. It becomes 0. So velocity of C is 0. In fact, velocity of the contact point in a rolling motion is always 0 because the surface has a 0 velocity. I'll talk about this more and how we can justify this if it doesn't make sense to you. So velocity of C is 0. Let's do it for velocity of D. Velocity of D is equal to what? Velocity of A plus velocity of D relative to A. Same story. Translate with A, rotate about A. VD slash A means what? VD slash A means find velocity of D as if A is fixed. Again, A is fixed here. I want to find velocity of D, right? So what is going to be velocity of D relative to A? Just the way that we got 80 inches per second here. Same story, 80 inches per second. But look at its direction. It's different now. It's downward, right? You see that? It's going like that. All right, so velocity of A is 80 horizontal. Velocity of D relative to A is 80 downward. When you add 80 horizontal plus 80 vertical, what do you get? You get actually 113.1. So the velocity of D becomes 113.1. Guess the angle is going to be 45 degrees, and that's inches per second. So velocity of D at this instant is going to be like this. 113.1, add an angle of 45 degrees. Doesn't matter, 45 here or there. All right, guys. I will do this problem for you using the IC approach, and you'll see how easy it is. You don't have to go through this business of translation and rotation anymore. So remember, relative motion is based on you breaking the motion into two parts, translation and rotation, and then you try to find velocity of it, another point. Okay, I hope this made sense to you, and stay tuned for more videos. Thanks for watching and listening.